We know the optimal substructure. We are going to start filling in the table using that formula. And one thing I will say right now is, as we fill in the table, we know this was our optimal substructure. So we have different values of k for which we compute this quantity, and then we choose the minimum of this quantity, and this quantity is what goes into your table ultimately, not the k values. But I will also keep a note of k values for the purposes of backtracking. Why and what is to be done with it, I will explain when we come to that. So right now, if things seem a little vague, stay with me while we do the example. So okay, we'll go back to the table we had. This is the table we had. Now I said we have to fill in these three diagonal elements first: dp1, 2, 2, 3 and 3, 4. So we will start with that. This is our array P, which was given to us in the question. This is our optimal substructure, which also we derived. We have to find whichever value of k this minimizes this. So we'll start with this one, dp of 1 of 2. This is I, this is j. So I equals 1, j equals 2. Now we know that k should range from I up to j minus 1. So here the only possible value that k can take is 1, because if k takes the value 2, it becomes equal to j, which is not possible. So I equals 1, j equals 2 and k equals 1. You straight up substitute the values, and this 15750 is the result you get. Similarly, you take dp2 of 3, I is a 2, j is 3. Again, k equals 2 is the only possible value that k can take. You substitute the values, you will get 2625. Similarly for 3 of 4. Now, so you get the values, you're going to put down the values, and the number in the braces represent the corresponding k values. So we have filled in the first diagonals elements. So what does this mean is, to multiply a1 cross a2, you need at least 15750 multiplications. To do a2 cross a3, you need at least 2625 multiplication operations, and to do a3 cross a4, you need at least 750 operations. Also, the number in the bracket, which is your k value, implies where you will make the split. So because in each of these cases you are multiplying only two matrices, obviously you will make the split in the middle. If it's a1 cross a2, the split is between a1 and a2. a1 is on one side, a2 is on one side, you just multiply. There is no regrouping to do at all. So you will say for 1 cross 2, the split is after 1, for 2 into 3, the split is after 2, and for 3 into 4, the split is after 3, which is very obvious because we are only multiplying two matrices at a time. So this is the first set of elements. Right, so now we fill the second diagonal element. So we want to start by filling this grid here, dp of 1 of 3. So I equals 1, j equals 3. Now if you see, the possible values of k are 1 and 2. So you substitute k equals 1 in the formula, dp of I of k plus dp of k plus 1 of j plus pi minus 1 pk pj. You will get this value 7875. If you substitute k equals 2, and again you look up the values and you substitute them, you will get 18,000. Now what does this mean? So dp of 1 of 3 means the minimum number of multiplications required to do a1 into a2 into a3. Now if k equals 1, then what we are doing is a1 times a2 a3. So you are doing a2 a3 first, and then you do a1 times that. If k equals 2, then what you are doing is a1 a2 times a3. So it's the same thing. We saw that ABC example, right? It is a times BC versus AB times C. That is what this case k indicates. So when your k equals 1, so when you do a times BC, you will need 7875 multiplications. If you do an AB times C, you need 18,000 multiplications. That is what this formula has told us. So obviously we are looking for the minimum, so we will choose k equals 1 and 7875. So you put in the value, and you put the number 1, which is the k value, within the braces. So what this means is, if you want to do a1 times a2 times a3, it is better to do a1 as one separate subset, have it as one set, a2 into a3 as one subset. So you do a2 times a3 first, and then you take a1 and multiply it. That is the optimal way to do it, and if you do that way, you will get 7875 multiplications. Similarly, you want to do the other grid on that diagonal, which is dp of 2 of 4. So I is 2, j is 4, k again can take the values 2, 3. So if you take k equals 2, you substitute, you will get 6000. If you take k equals 3, you will substitute, you get some 4000 something. Which means if you want to do a B into C into D, if you do it as B cross CD, it is 6000 multiplications. If it is BC cross D, 4375 multiplications. So obviously we will choose the latter. So you put a 4375 here, and where do you split? After the third matrix. So it is A2 A3 times A4. That is how you fill in the second diagonal. Fine. So now we have filled the first two diagonals. This is the grid we are looking to fill. So dp of 1 of 4, I equals 1, j equals 4. So the possible values of k are 1, 2, 3. For each of those values of k, you just plug in the appropriate numbers in the formula. You get these 14,000, 21,000, 9,000 some values. So this is again the minimum, which means if you want to do a A, B, C, D product, you do an ABC first times D. That is the optimal order. So you take that 9375, put it there and plug in the 3. So now that you have the final answer, this by the way is the final answer. So generally when you take a DP question, like at least the examples you did so far, the bottom rightmost cell was the final answer. But here if you see, dp of I of j is the minimum multiplications required for the product AI up to AJ. I have repeated this multiple times, but yeah. So and the original question asked us to find the product A1 into A2 into A3 into A4. So here your I is 1 and j is 4. So dp of 1 of 4 will be your final answer. So the minimum multiplications required to do A1 times A2 times A3 times A4 is 9375 multiplications. This is how you fill in the table. So I'll quickly give a recap and then we will move on to the backtracking and stuff. So you have these matrices, their dimensions are given to you in this array. Initially you will set up an n cross n table where the leading diagonal and lower triangular elements are 0 because either those multiplications are not defined or there are no multiplications at all. To fill in the upper triangular elements, you have this formula dpik plus dpk plus 1j plus pi minus 1 pk pj, and your k can be any value between I and j minus 1. So every time you take a grid, you know its I and j values, that is its row and column coordinates. So you take all possible values of k and you compute the this quantity for each k value. Whichever is the minimum, you will put in that value and the corresponding k value. So for the first diagonal, you will see there is only one possible k value in each case. So if your I is 1 and j is 2, then your k can only be 1. There is no comparison to do. Similarly for these two cases. In your second diagonal, you will see that there are 2 k values for each case. So for each possibility of k, you will compute the value of dpij using that formula given. Whichever be the minimum, you put that in the grid and you will also keep track of the corresponding k value. And for the third diagonal for this element, there were 3 possible k values. Again, you did the same thing. So, so finally you reach this answer. This grid contains the minimum number of multiplications for A1 times A2 times A3 times A4. And what is this k value is, like I already said, k is the place where you split that matrix product. So if I say dp of 1 of 4, I want to do A1 times A2 times A3 times A4. And if my optimal k turns out to be 3, meaning for k equals 3, I am getting the minimum number of multiplications, then it means I will split at 3, meaning A1, A2, A3, I will compute first and then I will multiply A4. So that is how you fill in the table and you reach the minimum number of multiplications.